Alrighty, so we are talking today about polynomials. This is the start of learning about polynomials, and I have my cute little gnome polynomials here that we get to take a look at. So, definition of polynomial. We're going to break it down into what are the two words that we see in polynomial. So the first one, I got to connect my pen here. My first piece of the word polynomial is poly, and the prefix poly means many. Okay, so when we have a polynomial, we have many, and then the nomial part means terms or parts. Okay, so a polynomial is many terms or parts. Well, what does this mean? We're going to write an example here that we're going to do some labeling. So we want to make sure we give ourselves enough room to label these different parts. My example of a polynomial here is going to be 5x squared plus 3x minus 4. Okay? This is a polynomial because it has many parts to it. And specifically, we're going to look at the first thing being the terms. And these are the pieces separated by plus and minus. So my terms are what I'm underlining here. They're the pieces separated by a plus or minus. And I'm going to label them a term, here's a term, and here's a term. Okay? Later today, we're going to use the word like term, and so we want to think about what we're talking about is breaking our polynomial apart into these pieces, okay? The next step is the variable. The variable is the letter, and it's a letter that represents a number. Let's spell this right. That represents a number. Okay, so our variables here are the x. Okay, those are our variables. If you want to use colors to help you organize your notes, that can be a good idea with this one. Okay. The next step is the coefficient, and the coefficient is the number that is multiplied by the variable. Okay? So it's the number we're multiplying by the variable. In this case, it would be 5 and 3, because those are the numbers that we are multiplying by our variable x. So this is called the coefficient. All right? The next piece we have is the exponent. We've talked about exponents before, maybe a little bit. Exponents referring to like the power. So another word for exponent is the power. It's the small number that multiplies the variable. Okay, so here we have two. This is our exponent. It's that small number. The value itself might not be small, but it's physically written small up in the corner. Next is our constant. Our constant is the number that is by itself. Okay. What color haven't I used? We're going to go back to purple. Or we'll use black. The number without a variable. Okay, so the number 4 is our constant. And lastly, we have the operator. The operators are the easiest ones to identify in my eyes. They are the plus or minus. Okay? So operator, operator. They are the ones doing the action between all the terms. All right? And the last piece that we have talks about the exponent. So if you look at the exponent on this polynomial, the biggest value exponent we have is 2. And so that is what's going to define what's called our order. So the order is the biggest exponent value. And it's what tells us essentially what kind of polynomial it is. So if it has the biggest exponent value is a 6, then it's called the 6th order polynomial. If the biggest one is a 5, it's a 5th order polynomial. Okay? All right, so let's look at an example here. We're going to go through and identify some of these key pieces just like we just did. Okay? So I'm going to start with underlining each term. Okay, so I'm looking at what are those things that are organized or separated out by a plus and a minus sign. Okay, so I'm underlining my terms. I got it. Now I'm going to circle my variables. So variables, remember, are our letters. So I'm going to circle that. I'm going to circle this X, and I'm not circling anything else other than the letter itself. Okay. Next thing I'm going to do, I'm going to highlight the coefficients in pink. Well, coefficient means the number out in front of the variable. So that would be 3 and 4 and 7. Okay. So I got that. Next, I want to highlight my exponents in yellow. Exponents are those little numbers written up top on the variable. So 3 and 2. Next, I'm going to box in my constant so I can identify my constant. My constant is the number by itself with no variable. So that would be 18. And I'm going to highlight my operators in green. Operators being my pluses and my minuses. Okay. So hopefully your paper looks something like this. Pause the video if you need some time to write it down. Okay. Identifying those different pieces. All right. So oftentimes we want to add and subtract polynomials in math, and when we're doing that, we want to pay attention to what are called like terms. They are our key to adding and subtracting, and like terms are terms, with the same variable and exponent. Now notice, but not always the same coefficient. Oops. Okay, so same variable, same exponent, not always the same coefficient. So some examples for you of some like terms would be something like 3x squared. Oh goodness, I'm losing my pen again. And 5x squared. Different coefficients, same exponent, or same variable, same exponent. Okay. Another example would be 4y to the 8th and 7y to the 8th. And sometimes we have situations where we have multiple variables at a time. So if I had something like x and y together, that would be a like term with 5xy. Okay, because they both have one x and one y with an exponent of, a secret exponent of 1. Okay? So some examples of like terms for you. We're going to go through and do some highlighting of like terms, all right? So what we're going to do here is we're going to say, I'm going to start with 5x cubed. When I have 5x cubed, I'm looking for something else that has the same variable, so x, and the same exponent, which is cubed. So I see over here I have x cubed. Even though my coefficient is different, it's the same variable and same exponent. And when I look at like terms, I want to also include the sign that goes with it. So in this case, I have a minus x cubed. So that is one pair. Go ahead, pause this video, and then go through and identify your like terms, and you can come on back and you can watch, okay? So hopefully you've done this for yourself. I'm going to keep going with this. I have 2y, and its like term is minus y. When I have negative 3x, my like term is negative 16x. When I have plus x squared, I have plus 27 squared, x squared. I'm going to skip over one here. When I have 4y squared, I don't have any like terms, so that is on its own. And then the two that I did not highlight are like terms with each other too, so I'm going to put a little star next to them to say that these two are also like terms to each other. Okay. So hopefully you can have done some identifying of your like terms. We're going to go on now to adding and subtracting our like terms. So I have two different situations here. We're going to handle them the same way. But to add and subtract polynomial expressions, we are going to combine like terms. That is our key. Using the operations given. So if there is a subtraction, we're going to subtract. If there's addition, we're going to add. I have two polynomials here in my first example. I have this one on the top that I'm circling right now, and I have the one on the bottom that I am underlining, okay? These are both separate polynomials, and they are being added, okay? So between each set of like terms, we are going to add to get what our polynomial adds together to get. Now, I can only combine things that are like terms. I cannot combine or subtract pieces that are not like terms. So what I'm going to go through is go through and highlight my like terms. So I'm going to start with 2x squared. When I look at 2x squared, my like term for it is 3x squared. So those two are going to go together. And I'm going to write that out as what they're being added. So I have 2x squared being added to 3x squared. My variable and my exponent stay the same. That's what maintains that they're like terms. So the only thing I'm going to combine is my coefficients. So I have 2 plus 3, which is 5. So my answer is 5x squared. Now I'm going to go through and do that with my next set of like terms. 3x and minus 5x. So I'm going to go and write those in now as a combination. Now I want to warn you, right now we only have two sets of like terms, or two pieces in our like terms. Sometimes you will have more than that. So you want to make sure you look and check for all of them. Okay? All right, so I wrote 3x plus negative 5x. I know my x is going to stay the same, so what I'm looking at is my coefficients. Now, sometimes it's confusing when we have plus minus, so remember you can also write this as 3x minus 5x, because whenever you have a plus and a minus together, they become a minus, okay? So 3x minus 5x is like 3 minus 5, which is going to get me negative 2. So I have negative 2x. And I'm going to do one more for you because we have one more set of like terms. I have plus 2 and minus 1. So I highlighted my like terms so I know where they are and can use them and write them. And now I'm going to do plus 2 minus 1, which is the same as saying 2 minus 1, which is equal to positive 1. Now that I have these pieces, I can write my answer, okay, by putting all of these pieces together. So I have that the addition of these two polynomials up here is equal to 5x squared minus 2x plus 1. Alrighty. And we're going to follow the exact same process with this set of polynomials in example 2. The only difference is that we are subtracting. So between each set of like terms, we are going to subtract to get our solution. So my first job is to find like terms. I'm going to start with 5x squared, and what is combined with that? Well, it's 4x squared is my like term because they both have x squared. So I have 5x squared minus 4x squared. My x squared stays the same. Only thing that combines is my coefficient. So I have 5 minus 4, which gets me 1. Oh, goodness. That is not what I meant to do. All right. Next, I'm going to find my next set of like terms. If I can find a highlighter. Here we go. And I have negative 14x plus 8x, which is going to give me negative 14x plus 8, or plus a minus 8x, which is the same as saying minus x. So negative 14x minus x, the x, 8x, the x stays the same. If I'm at negative 14 degrees out and it gets 8 degrees colder, we're going to be even more negative at negative 22x. And lastly, I have my negative 15 and my positive 10. So I'm going to combine those as negative 15 minus a positive 10, which is the same as saying negative 15 minus 10, or negative 25. So my solution when I subtract these two polynomials is x squared, or 1x squared, minus 22x minus 25. One thing that I would like you to note in the additional notes section of your notes is that order matters. Ooh, that does not look like what I wanted to say. Let's see. Order matters. So the first polynomial comes first in subtracting. Okay, when you are subtracting, the first polynomial, so whatever is on top or written first, this one will always go first in your subtraction. If you switch them around, you will get an inaccurate answer. So please make sure that you have these ones going first. Okay? All right, that is what we have for adding and subtracting polynomials.